Star Earth's velocity would have to be faster in order to not be pulled into the stars, either that, or its orbit would have to be slightly further out if we wanted to maintain our current velocity. The increase in temperature from the star would be noticeable too, definitely making it unbearable for humans. But exactly how hot would depend on a variety of factors, like a runaway greenhouse effect, the heat of the star, and more. But let's say we place Earth's orbit in such a location that we can survive. Seasons would still be massively impacted, as the tilt of the planet would be secondary to the distance to the second star, when the second star is as far away as possible, and the hemisphere on Earth was also experiencing winter. It would get extremely cold. On the other hand, combine a summer with the second star passing as closely as possible, and it will be incredibly hot. Additionally, a curious phenomenon with red dwarfs is that they also produce huge flares, much larger than the ones our sun produces. They would easily knock satellites offline on a regular basis, and Earth would have some spectacular aurora. Our power grid as it stands would also be under serious threat from these stellar flares, as they would act like hemisphere-wide EMP bombs. The interactions with this second star could well make our sun more active too, meaning it, too, may produce more flares. So even with the smallest type of star, a habitability on Earth would be under serious threat. Increase the mass of the second star, and you'll start to get additional problems, like increased UV radiation making going outside more and more dangerous. You'll also have two shadows. A lot of the time, once you turn the second star into something like a blue supergiant, there really won't be a place in the system where there is even a hope of habitability. Blue supergiants can be many times the mass of our sun, the theoretical limit being 150 solar masses. Their volume is also big. They make the sun look almost puny in comparison. They can be millions of times more luminous than our sun. Two with devastating stellar winds, enough to rip our atmosphere off over a relatively short time frame. Larger again are yellow supergiants and then red supergiants. While not as massive or as luminous as blue supergiants, red supergiants are the biggest stars in existence. If you plop the largest known of these stars directly into the center of our solar system, not only would they easily encompass Earth, but it would encompass everything up until Saturn. That's 10 billion times the volume of our sun. However, there is a scenario where we could be in a binary star system with a supergiant and still be on a habitable planet. You see, binary stars can orbit very far apart, taking thousands of years to complete one orbit. The most extreme cases can see a binary star system with a separation of over 1 light-year. And what can happen is that planetary systems form around each of these stars separately, meaning that if Earth was in one of these planetary systems, it would only have the one parent star, even if that star was part of a binary. The second star would be easily visible in the night sky, but may not make much of an impact during the day, depending on its luminosity. Stellar winds from the other star would have little impact on Earth, as our sun's powerful magnetic field would redirect most of it away. The big problem with a supergiant on your doorstep is that it is a ticking time bomb. Supergiants tend to be on the verge of erupting in a supernova. A supernova going off only 1 light-year away would be catastrophic, probably sterilizing the entire planet as radiation from the shockwave passes over. And that's not to mention the gamma bursts from the resulting neutron star. In fact, a recent study has suggested that being within 50 light-years of a supernova going off would be close enough to be catastrophic in nature. However, the good news is that we don't know of a star capable of erupting in a supernova within 100 light-years, going back to the single parent star, binary star configuration on Earth with a single sun. We have a set day and night cycle. However, should we have a second sun outside of our orbit, but still pretty close to us, is going to mess with our day and night cycle pretty badly. There would only be tiny parts of the year where you would get a proper day and night cycle, and as the year progresses, you would get less and less of a night, until at one point where you'd have no night at all. So there we have it, while having a second sun. During a sunset seems like it could be an amazing prospect. At first glance, delving into the details reveals that we are extremely lucky to only have the one sun, no matter what configuration you look at. There are some major problems with the second star, be it devastating solar flares, a ruined day-night cycle, having a neighbor that might explode at any moment, having our orbit completely eaten up by the volume of the star, huge swings in seasonal temperature, changes, having our electronics fried out regularly, UV radiation, and likely more that I haven't mentioned in reality. Even if life as we know it does exist around binary star systems, they have some major obstacles to overcome to get to where we are now. So let us be grateful for our boring but steady and safe star. The sun long may it continue to be so often on a clear day. I will briefly glance at the sun and be in awe about how big and bright it is in our sky. It's hard to think that it's millions,